spring of 1942 found two engineers standing nearly 8 miles apart on the grounds of Fort Knox, Kentucky. Each held a prototype radio device in his hands, equipment that would fundamentally transform how soldiers communicated across battlefields. Daniel Noble, serving as Director of Research at Galvin Manufacturing Corporation, raised his transmitter to his lips and pressed the button to broadcast his message. The words emerged with startling clarity, traveling invisibly through the air via frequency modulation technology. Miles away, his colleague Henry Magnuski received those same words with perfect, undistorted reception. The military had originally demanded a minimum operating range of just 3 miles as the baseline requirement. Yet Noble's engineers had already shattered that expectation in their testing phase, achieving more than twice the distance without difficulty. What made this moment even more striking was the path taken to reach it. The Army had originally insisted that all portable radios use amplitude modulation, the AM technology everyone understood and trusted. Noble had fought hard to change their minds, arguing passionately that AM was simply wrong for battlefield use. That decision to pursue frequency modulation instead of following the military's original mandate would prove to be the turning point. The SCR 300 walkie-talkie under development would deliver reliable communication across 3 miles during actual combat operations, with potential to stretch 5 miles under ideal circumstances. This represented a dramatic leap forward, roughly tripling the performance of existing handheld radio equipment. One senior military commander would eventually describe it as the most valuable communications tool used throughout the entire European campaign. This is the remarkable story of how an engineer's unwavering belief in superior technology transformed warfare and helped shape the course of World War II itself. That breakthrough journey actually began in September 1940, when Daniel Earl Noble walked into Galvin Manufacturing Corporation in Chicago to take on the role of Director of Research. Born on October 4, 1901 in Norwalk, Connecticut, he had earned his engineering credentials from the University of Connecticut and already established his reputation by creating America's first statewide two-way FM radio network for the Connecticut State Police, completed in 1940. He possessed deep knowledge of what frequency modulation could accomplish: superior noise suppression, crystalline clarity, and rock-solid dependability in environments where electrical interference plagued traditional AM systems. Noble arrived at Galvin Manufacturing during a moment of profound consequence in American history. The war consuming Europe was intensifying by the day. Germany had swept across France in June 1940, crushing the nation with shocking speed. Britain now faced the Nazi onslaught alone, its cities enduring relentless bombing campaigns while RAF pilots battled for survival in the skies. America had not yet entered the conflict, but to those paying attention, involvement seemed not a matter of if, but when. President Roosevelt had already begun accelerating military production and readiness. The American armed forces faced an enormous undertaking to rebuild, retrain, and re-equip for a conflict of unprecedented scale and brutality. One of the most serious gaps remained battlefield communications, an area where American forces lagged dangerously behind what modern warfare demanded. The new warfare unfolding in Europe required coordination across vast distances and among enormous numbers of units operating simultaneously. Squad leaders needed contact with company command. Soldiers in forward positions needed to direct artillery strikes with speed and accuracy. Tanks and infantry needed to work together as unified fighting forces. Officers at every echelon required instant communication to maintain control and issue rapid commands as situations changed and evolved. Yet the radio equipment available in 1940 was woefully inadequate for these demands and realities. The Army had attempted portable infantry radios during the late 1930s, producing models designated SCR 194 and SCR 195. These early experiments had proven to be spectacular failures. They relied on primitive circuitry that worked unpredictably and often failed completely when soldiers needed them most. Operating on AM frequencies left them vulnerable to overwhelming interference and noise. Every running engine, every electrical motor, every lightning storm Every piece of electrical gear generated static that completely buried the signal beneath waves of noise. The frustration was so severe that many infantry officers simply gave up on radio communications entirely, preferring to send runners carrying handwritten messages despite the obvious dangers and delays that approach created. At least runners didn't suddenly fail at critical moments. Galvin Manufacturing had already demonstrated capability in military radio with their handheld transceiver, the SCR 536, affectionately nicknamed the Handy Talkie. Don Mitchell, the company's chief engineer, had led that development effort, and his success had impressed the Army sufficiently to award production contracts. Word spread that President Roosevelt's Secret Service had adopted the Handy Talkie for presidential protection even before America entered the war after Pearl Harbor. For its time, the SCR 536 represented genuine innovation and achievement. It was compact and truly portable, with microphone, speaker, batteries, and antenna all integrated into a single device weighing just 5½ pounds, operable by a single soldier using one hand. It operated on high-frequency AM bands between 3,500 and 6,000 kilocycles, with crystal control for stable frequency performance, a meaningful improvement over previous designs. Yet the SCR 536 suffered from one fundamental limitation that no amount of refinement could overcome. Its effective operating range reached only about 1 mile under favorable conditions. This sufficed for communication within a single platoon, or between squad leaders and their sergeant, or potentially between a company commander and his platoon leaders if they remained relatively near. Beyond that narrow radius, it became essentially useless. Company-level commanders lost contact with battalion headquarters several miles away. Observers calling in artillery fire from distant positions found themselves unable to reach the gun batteries they were directing. Tank platoons attempting coordinated operations with infantry companies found the radios incapable of bridging even short distances. The 1 mile limitation created a critical gap that modern mobile warfare simply could not tolerate. In September 1940, shortly after joining Galvin Manufacturing, Noble accompanied Don Mitchell to Fort Monmouth, New Jersey, to demonstrate the Handy Talkie to Army Signal Corps leadership. Present that day were 2 Signal Corps officers whose decisions would prove absolutely crucial to portable radio development. Colonel Roger B. Colton directed the Signal Corps laboratories, having held that position since 1938. Major James Don O'Connell served as executive officer and was beginning to take on responsibility for radio communications projects. The Signal Corps officers respected the Handy Talkie's performance and innovation, but they communicated clearly that much more capability was needed. They required a radio with substantially greater range, yet still light and portable enough for infantrymen to carry and operate during combat. They wanted a radio bridging the gap between company and battalion-level communications. They envisioned equipment reaching back 5 or 10 miles to higher command posts. They needed equipment functioning reliably in the electromagnetic chaos of mechanized warfare. In response to these requirements, the Signal Corps issued contracts for development of a new portable AM radio system in 1940. The military's decision to specify AM technology made a certain sense at the time. AM was established and proven. Military leaders understood AM technology, trusted it completely, and had built their entire radio infrastructure around it. All radio operators throughout the military had trained on AM equipment. Repair personnel knew AM maintenance and troubleshooting. The supply and logistics networks were designed entirely to support AM equipment. From an institutional perspective, AM represented the safe, conservative approach that minimized risk. When Noble learned of this decision during meetings in Washington, his reaction was immediate and forceful. He directly confronted Major O'Connell, stating bluntly that specifying an AM radio represented a grave strategic error. The Signal Corps, Noble insisted, should instead contract for an FM portable radio system. This was an astonishingly bold position to take with senior military procurement officials. Noble was essentially accusing the Army of making a fundamental technical mistake. He was challenging the military's established preference directly. He was proposing a more complex and potentially costlier alternative. He was asking military leadership to gamble on an unproven technology when established approaches were available. AM was familiar and comfortable. FM was newer, less familiar, and many radio engineers considered it impractical for portable military use. FM required broader frequency bands than AM, meaning fewer distinct channels could fit within available spectrum allocations. In an era when radio bandwidth was viewed as an increasingly scarce and critical resource, this disadvantage seemed troubling and potentially outweighed FM's merits. FM circuitry demanded greater sophistication than AM equipment, raising questions about reliability in harsh field conditions and whether military maintenance people could keep the equipment operational. FM systems required more advanced components and more precise tuning and adjustments than comparable AM equipment. But Noble possessed technical understanding that many contemporary radio engineers lacked. He grasped that FM offered fundamental, genuine advantages that would prove worth far more than the additional complexity and cost. FM inherently suppressed electrical interference and noise in ways AM simply could not accomplish. FM maintained clear voice transmission even at extreme range limits, while AM signals degraded into progressively worse static and useless noise as distance increased. FM would function reliably amid the electromagnetic chaos of battlefield conditions, near-running engines and electrical gear, in situations that would render AM radios essentially worthless. Noble had witnessed this firsthand with the Connecticut State Police FM system, where clear communication persisted in conditions where AM would have failed completely. Noble's deep conviction about FM superiority, combined with his strong technical credentials and proven accomplishment, ultimately persuaded the military leadership. Major O'Connell, won over by Noble's technically sound and passionate advocacy, directed the Signal Corps to issue a development contract to Galvin Manufacturing for an FM portable radio system. This radio would receive the designation SCR 300, Signal Corps Radio Number 300. That contract launched one of the most demanding, yet ultimately most successful engineering endeavors of the entire Second World War. Back in Chicago, Noble immediately began assembling an exceptional engineering team. His core group consisted of some of the most talented engineers the company could recruit. Henry Magnuski, who had emigrated from Poland and would become one of the company's most celebrated engineers, assumed the role of principal RF engineer, responsible for developing the radio frequency circuits that would determine whether the entire project succeeded or failed. Marion Bond, Lloyd Morris, and Bill Vogel completed the core team, each contributing specialized knowledge in different radio design disciplines. They would require every bit of their combined skills and experience because the Army's demands for the SCR 300 were extraordinarily stringent. The SCR 300 had to run on batteries while maintaining sufficient power capacity for extended field operation without frequent battery replacement. It had to weigh no more than 35 pounds, including all batteries and accessories, light enough for an infantryman to carry on his back for long periods during active combat while still possessing full capability to fight when required. It had to maintain reliable communication across at least 3 miles, even through challenging terrain, across forests, over hills, in real conditions far more demanding than simple line-of-sight transmission. The design had to be waterproof, able to handle torrential downpours and the relentless moisture that came with operating in field conditions without breaking down. Soldiers with only basic technical training needed to be able to use it effectively, even when chaos erupted around them and fear clouded their thinking. The radio needed to work across a spread of frequencies from 40 to 48 megacycles, giving different military units their own channels so they wouldn't jam each other's signals. And here was the real problem. With wartime manufacturing stretched impossibly thin, engineers could only use 2 frequency control crystals. Crystal production had become the chokehold in radio manufacturing, and as the war machine demanded more and more equipment, that bottleneck would only get tighter. Trying to meet all these demands at once seemed almost impossible. Each single requirement was tough enough on its own. Pile them together, and you had an engineering nightmare that kept people awake at night. But Noble's group had something working in their favor, something massive. They'd chosen to use FM technology, and FM had built-in advantages that could solve some of their biggest headaches. Late in 1940, After putting together his team and getting the official go-ahead, Noble made a decision. He called Henry Magnosky and Andy Affronti, a bright young engineer fresh to the research lab. He asked them both to gather at Affronti's workbench, positioning Magnosky on one side and Affronti on the other. Then he laid down an official-looking document between them. Affronti caught sight of the heading right away, United States Army Signal Corps. Noble went through the 8 key requirements one by one, walking them through each specification for what would eventually become known as the SCR 300. When he finished, he said something neither man would ever forget, words that became etched in their minds. "Henry and Andy, I need you starting on this right now. When I was down at the Signal Corps, they made clear this is life and death. Infantry soldiers are counting on this. You'll get whatever resources you need, and I want to see a working prototype built as quickly as possible." Stunned by how serious this was and by the weight of what he'd just handed them, Magnosky and Affronti looked at that single sheet of paper over and over, taking in every word. The Army Signal Corps wanted them to build a portable infantry battalion radio, the SCR 300, that could both transmit and receive. This device needed batteries to power it. The finished unit couldn't weigh more than 35 pounds, light enough for a soldier to carry into combat on his back. It had to send clear signals 3 miles out. Rain couldn't wreck it. Just 2 crystals were allowed, and it needed to cover frequencies continuously from 40.0 to 48.0 megacycles. The task seemed almost impossible, and yet this was their chance to change everything. If they pulled this off, American troops would have communications ability no other army had ever had. Working frantically, pushed forward by the knowledge that real soldiers' lives hung on whether they succeeded or failed, Noble's team came up with designs that broke new ground in several directions. They engineered a single tuning knob that would tune both the transmitter and receiver at the same time, cutting out the need for soldiers to fiddle with separate controls for sending and receiving. It looked simple on the surface, but it was technically sophisticated, and it made operating the radio under fire dramatically easier. They built in automatic frequency control that would grab the right frequency and hold it steady without drifting, keeping communication clear without needing the operator to be some kind of precision tuner. That mattered enormously, because combat soldiers couldn't be expected to have the technical training, or the calm hands, or the free attention to dial in radio frequencies while bullets were flying or while scrambling through rough ground. They solved the battery power problem by building circuits that ran efficiently on battery power while still giving the transmitter enough punch and the receiver enough sensitivity to work properly. In 1940, batteries were crude compared to today, and squeezing enough juice out of them for solid radio work without making the batteries so heavy the whole unit went overweight took sharp thinking and careful choice of parts. They tackled the moisture problem by coating components with special treatments so the radio could survive the steamy heat and dampness of Pacific combat zones. And they did all this while keeping total weight at or just under 35 pounds, though the final version with all the batteries would tip the scale a bit higher. The SCR 300 that came out of their months of hard work was an 18 battery-powered VHF battlefield radio using FM. Both the transmitter and the double super heterodyne receiver were built around FM technology, pulling in all of FM's advantages, its noise-busting power and its ability to stay clear and loud right at the edge of range. The radio had an adjustable squelch circuit, something brand new to military radios and something that would make a huge difference in actual use. With standard AM radios, operators had to sit and listen to endless hissing and crackling static whenever no one was talking. That constant noise wore on the mind and made it easy to miss transmissions coming in. The squelch circuit shut down the receiver when nothing was being sent, sparing operators from that mental exhaustion and making it unmissable when a message arrived. When silence suddenly broke into sound, it grabbed attention in a way that changing static levels never could. The automatic frequency control kept the frequency rock solid across every channel without the operator having to keep fiddling. The crystal calibration circuit let operators quickly check that they had the right frequency set, making sure everyone on the same channel was actually listening on exactly the same wavelength. The tuning setup was beautifully straightforward from the user's angle. just one control knob and a channel readout showing channels 0 through 40, giving 41 channels total spread across 40 to 48 MHz with 200 kHz between each channel. Two frequency crystals working on harmonics gave the calibration reference points that let the tuning mechanism hit all 41 channels accurately. This was a clever solution to the two-crystal limit, using harmonic relationships and careful frequency construction to get all the frequencies needed from just two crystal sources. The entire setup could work in relay or retransmission mode, allowing two SCR 300 units to stretch communications distance far past what line of sight would normally allow. One radio would pick up a transmission and instantly retransmit it, effectively doubling or tripling the range without asking anything of the operators except to flip a switch. This relay feature would prove essential in mountainous country or when headquarters needed to stay connected with forward units sitting beyond direct radio reach. By spring 1942, Magnosky, Affronti, and their teammates had two working prototypes ready for evaluation. The prototypes meant over a year of around-the-clock engineering, countless nights burning midnight oil, dead ends and failed experiments, and the kind of single-minded problem-solving that defined American engineering excellence during the war. On a warm spring day at Fort Knox, the real test arrived. The moment that would confirm whether Noble's belief in FM technology and his team's year of grinding work had paid off. Magnosky and Affronti positioned themselves 8 miles apart, far beyond the 3-mile range the Army had demanded. Standing on the flat roof of a building with his prototype, Magnosky pressed the transmit button and spoke. 8 miles away, way past the specified distance, Affronti heard every word perfectly clear. They tried again and again, jumping between frequencies, testing different channels, putting the radios in different spots and different angles. Every single time, the prototypes worked flawlessly, showing range that demolished the Army's requirements. When Signal Corps observers showed up days later for their official evaluation, they saw demonstrations that impressed them enough to greenlight production development right then and there. More development and polish brought the production version of the radio, called the BC-1000. This complete SCR 300 walkie-talkie system included the radio unit plus everything needed: battery pack, carrying harness, antenna, and handset. The final weight came to around 38 pounds with the larger BA-70 battery, or 32 pounds with the smaller BA-80 battery. This ran slightly over the original 35-pound target, but the Army figured the extra weight was worth paying for how well the radio worked and held up. Before the Army gave the go-ahead for full production, the production SCR 300 went to Fort Knox, Kentucky, where the Armored Force School ran their operations. In the forests, fields, and rolling terrain around the base, the radio went through every kind of testing imaginable to check every aspect of its performance. How it handled rough field work, and whether ordinary soldiers could operate it without trouble. The Infantry Board, an organization throughout the Army known as extremely harsh judges of communications gear and deeply suspicious of manufacturer claims, was invited to watch. Over the years, this board had shot down plenty of equipment, and their sign-off meant something. Bob Galvin, whose father Paul had founded the company, flew to Fort Knox with Dan Noble and Bill Vogel for these make-or-break trials. The pressure was enormous. They had just 2 production models, and if something went sideways during testing, if the radios fell short, the whole program could blow up. Night after night during the testing, the team went back to their hotel and went over both radios with a fine-tooth comb, checking every piece and every connection, making absolutely certain they'd be ready for the next day. The SCR 300 performed even better than Noble had hoped during those Fort Knox trials. The radio came through perfectly clear, even with interference from vehicle ignition systems, proving in the real world that FM's theoretical protection against electrical noise actually worked in the field. The radio kept functioning after rough treatment, drops, rain exposure, and all the wear and tear that military equipment faces in actual use. The solid design, both the mechanical parts and the electronics, showed in how tough the radios were. They survived conditions that would have destroyed more fragile equipment. The Infantry Board officers, men who'd watched countless pieces of communications equipment fail to live up to what manufacturers promised, reacted with remarkable enthusiasm. This radio actually does what they said it does. It works when AM radios would be basically useless. It's built tough enough for real combat. Soldiers can actually run it without problem. The infantry board approved it, and that approval carried more weight than any lab test could have. The Signal Corps placed production orders. Galvin Manufacturing, which would officially become Motorola in 1947, ended up building nearly 50,000 SCR 300 units throughout the war. Fresh units rolling off assembly lines were rushed by plane to fighting forces in combat zones. The military pushed this so hard because the North African and Sicilian campaigns had shown just how badly communications problems could hurt operations. Messages hadn't gotten through when they mattered most, leaving commanders without information and unable to act. Different units couldn't work together on attacks. Artillery couldn't adjust fire in real time because observers forward couldn't hold steady radio contact with the batteries firing the guns. These communication breakdowns had killed men and wrecked combat effectiveness. In August 1943, New Georgia, a volcanic island in the Solomon Islands, became the location of vicious fighting as American forces fought their way forward in their island-by-island push across the Pacific toward Japan. The SCR 300 arrived here for its first real combat use in the Pacific, showing up right when troops needed it most in some of the worst communications terrain on Earth. Colonel Ankenbrandt, the signal officer managing all communications across the Pacific, tested the new radios in actual jungle fighting. At first, he was seriously doubtful the SCR 300 would work in Pacific combat. Earlier in 1943, when he learned that the older SCR 511 radio was being swapped out for the SCR 300, Ankenbrandt had actually filed a protest to his commanding officers. He figured VHF radios like the SCR 300 wouldn't work worth a damn in thick jungle fighting. His doubts made technical sense. The Pacific climate destroyed electronic gear. Dense jungle growth swallowed up radio signals and scattered them in every direction. Most Pacific islands were mountainous, creating dead zones and radio shadows. All of this seemed to prove that VHF wouldn't cut it, and that lower frequencies with longer waves would work better by getting around obstacles. But once the SCR 300 arrived in quantity and troops actually started using it in real fighting, Ankenbrandt's thinking did a complete turnaround. How the FM radio performed in jungle surprised absolutely everyone, even the skeptical signal officer. By January 1944, after months of actual combat use, Ankenbrandt was sending glowing reports up the chain to General Millikan. The SCR 300 sets have now seen action in the Torokina area and Bougainville in the hands of the 37th Infantry Division and the 43rd Infantry Division. From the very first field reports that came across his desk, the skeptical signal officer couldn't deny what he was reading. These radios, he noted, delivered exactly what frontline troops needed for battlefield communications in this theater. Coming from someone who had publicly doubted whether the radio was worth deploying at all, this represented a major breakthrough for Nobles and everyone on his engineering team. Ankenbrandt's documentation highlighted one persistent operational headache, though: keeping enough fresh batteries in the hands of soldiers who needed them. The BA-70 and BA-80 power cells that fed the SCR 300 burned through their charge quickly in the Pacific's unforgiving heat and moisture. Combat operations in dense jungle terrain drained those batteries far faster than training exercises in temperate zones had suggested they would. Yet this wasn't a flaw in the radio itself. It was purely a matter of supply chains and logistics. The radio gave field commanders exactly the communication tool they desperately required to manage their troops effectively when fighting turned into close, chaotic jungle engagements. Second Lieutenant Joseph Dewey, who handled communications for the 298th Infantry Regiment, gathered real feedback from the actual soldiers lugging these radios through combat zones and using them under enemy fire. One complaint surfaced again and again in combat reports. The harness that held the radio didn't distribute its weight properly. Too much burden settled low on the carrier's back, leaving them exhausted after pushing through difficult jungle trails for hours on end. The metal brackets securing the radio to the belt had a nasty habit of jabbing painfully into the operator's sides during movement, draining energy and adding to the general physical punishment of jungle warfare. These represented genuine comfort and mechanical problems that could be, and eventually would be, fixed through better harness designs. But they didn't touch the fundamental value of the radio as a tactical tool. When Dewey wrapped up his formal assessment, he wrote something powerful. The SCR 300 was an infantryman's dream, giving troops radio communication and command control capabilities beyond anything they'd ever had before. Those words, from a junior officer who had personally led infantry soldiers through jungle combat and intimately understood what they faced, represented the exact kind of endorsement that Nobles and his team had been working toward. The radio functioned in actual field conditions. It worked when bullets were flying. It gave infantry officers a capability that simply didn't exist before. The Pacific's tropical environment presented grueling challenges for any electronic equipment, not just communications gear. Earlier versions of the SCR 536 handy-talkie had deteriorated with shocking speed in jungle settings, with some units becoming completely dead within just 36 hours as rust, moisture, and fungal growth rendered them useless. The failures happened so violently and so quickly that units risked losing all radio capability whatsoever. Signal Corps engineers tackled this by creating specialized tropical treatments. They developed special fungus-fighting shellac coatings that got painstakingly brushed onto each component and then heated in precise conditions to guarantee they'd stick and cover completely. Every single radio and electronic unit heading to the Pacific received these protective treatments. The specially treated SCR 300 sets resisted the jungle environment far better than anything that had come before. Rather than dying in days, these protected radios held up through weeks and months of continuous operations, needing nothing more than routine care and battery swaps. This remarkable durability in such hostile conditions proved the soundness of the radio's fundamental design and showed just how effective the specialized tropical coatings truly were. Come September 1943, American and British troops began pouring ashore on the Italian mainland at Salerno and Calabria, establishing a new battleground in Europe and starting the grueling advance up the peninsula. The SCR 300 made its European debut during this invasion. Radio operators struggled through ocean waves with 32 to 38-pound sets strapped across their shoulders, stormed through German artillery barrages and machine gun salvos, and immediately started building communication networks while the battle raged all around them. In those first frantic hours and days, when soldiers were scattered and confused, when commanders were scrambling to establish order and direct their men, the SCR 300's value became strikingly clear. Company officers could speak directly to battalion headquarters, positioned miles away, either still aboard ships or operating temporary command posts just inland from the shore. As companies pushed deeper into hostile territory, they kept radio contact, even when hills and ridgelines cut off direct sight lines. This shocked commanders who were accustomed to going silent the moment their units moved any distance or disappeared behind hills. Forward observers, among the first soldiers to get significant numbers of these radios, suddenly could request artillery strikes with remarkable speed and certainty. These spotters would move to observation points, sometimes several miles from their artillery units, scanning for enemy locations, movement and troop concentrations. When they spotted something worth hitting, they'd transmit exact coordinates back to the guns. The batteries would fire, the observers would track where the shells landed, then radio back precise adjustments for the next volley. This observed fire cycle, absolutely essential for effective artillery support, demanded completely reliable communication between observer and battery. Before this, AM radios had let units down repeatedly when they needed them most. Static and radio noise would blank out observers at critical moments. Messages came through garbled and twisted, forcing frustrated repetitions that burned up precious seconds. Observers would watch German troops walking into perfect killing zones and be powerless to call in fire because their radios simply wouldn't work reliably at distance or in the electromagnetic chaos of active combat. The SCR 300 transformed everything. The FM transmission sliced through the electrical chaos and static that always fills a battlefield. The signal was so clean that coordinates could be sent and confirmed immediately without repeating or second-guessing. Artillery missions that once demanded many minutes of back-and-forth radio chatter could now be executed quickly and accurately, often in a fraction of the time. The soldiers actually using these radios in live combat discovered quickly how practical and dependable they were. The US Army was still learning its way through 1943, testing new tactics against battle-hardened German forces who had been fighting since 1939. American forces were figuring out how to wage modern combined arms warfare against a capable and stubborn opponent. And that learning process came with terrible casualties and painful reversals. In this difficult situation, the instant radio contact provided by the SCR 300 became invaluable to fighting men and their officers at every level. When German forces hit an American position suddenly, and a unit needed reinforcements immediately to avoid being overrun, company commanders could radio for help and have reserve troops moving to their aid within minutes, rather than the hours it might take for a messenger to walk back through rough ground and enemy fire. When German soldiers launched counterattacks that threatened to shatter a defensive line, SCR 300 operators could call down concentrated artillery barrages that shattered the assault before it broke through. The radio proved literally as valuable as gold to men whose survival hinged on being able to speak with supporting units and commanders above them. Throughout 1943 and into 1944, as production ramped up, SCR 300s went out in growing numbers to additional units and to other military branches besides Army infantry. The Marine Corps, Army Airborne Divisions, Army Air Force Forward Controllers, and Navy Landing Force personnel all received their allocations. The Marines absolutely loved what this radio could do. In the Pacific, where thick jungle and rugged mountains made radio work extremely tough, and where units could vanish and get trapped with terrifying speed, the SCR 300's capacity to transmit reliably across several miles gave Marine officers a level of tactical control in jungle operations they had never experienced before. June 1944 arrived, bringing with it one of history's most pivotal moments at the coastline near Normandy, France. Operation Overlord, the most massive and intricate amphibious assault ever attempted, was launching. Something like 6,900 ships of every description transported roughly 156,000 Allied soldiers toward the Normandy beaches to start the push to free Western Europe from Nazi tyranny. The assembled fleet looked endless when you looked out at it. Packed carefully into those landing craft, sealed tight against saltwater spray and guaranteed to get dunked, were thousands upon thousands of SCR 300 radios. The hard-won lessons about battlefield communications from Italy and the Pacific had sunk deep into the invasion planning team. Commanders made certain that every unit that could use the SCR 300's capabilities got enough of them. When the opening assault waves reached Omaha Beach, Utah Beach, and other landing zones in the pre-dawn darkness of June 6, 1944, radio operators carrying SCR 300s splashed through the surf and crossed the beaches. Pinned down by devastating German artillery, mortar and machine gun fire, with men bleeding and dying around them, those radio operators had to build and hold together communication networks absolutely vital to invasion success. The contrast between the SCR 300 and the older AM sets became obvious and powerful right away in the noise and electromagnetic turmoil of the invasion beachhead. The landing zones descended into nearly total chaos. Hundreds of landing craft with engines screaming, tanks, earth movers, trucks, and all the machinery of war created an electrical environment that produced immense radio interference. An AM radio in that environment would have drowned in ignition noise and electrical garbage spilling from thousands of running engines and electrical systems. The SCR 300's FM transmission punched through all that noise as though it wasn't even there. Maintaining sharp communications when sharp communications meant the difference between achieving the objective and experiencing disaster. Officers commanding battalions on the beach could speak to regimental commanders positioned on offshore vessels or at command posts being set up just inland from the shore. Artillery observers attached to assault units could direct naval gunfire from the tremendous weapons aboard battleships and destroyers against German fortifications and strongpoints. And those communications stayed clear enough to direct accurate fire missions right through the middle of fighting. As soldiers moved inland from the beaches across the distinctive terrain of Normandy, The SCR-300 kept units connected through landscape that would have silenced AM radios completely. One specific capability of the SCR-300 became vital during the Normandy operations: the repeater or relay function built into its design. Two SCR-300 sets could be configured to automatically bounce signals between them. This stretched the radio's range far beyond what a single unit could achieve, and allowed communication through hills and natural obstacles that would otherwise have blocked signals entirely. In the fierce struggle through the bocage, those distinctive Normandy hedgerow fields, where thick earth banks topped with hedges split territory into isolated compartments and created natural fortress lines, that relay capability saved lives. Relay stations allowed regimental commanders to keep talking to forward battalions, positioned several miles distant behind multiple rises and through numerous hedgerows. The precise engineering of the automatic frequency control and crystal stabilization meant relay operations ran smoothly without requiring constant manual tuning or experienced operator expertise. Signals remained sharp, frequencies stayed locked, and messages flowed as designed, even when relay operators were working under fire with 100 other things demanding their attention besides fiddling with radios. An urgent request submitted on June 21, 1944, only 15 days past D-Day, asked for 200 additional SCR-300 units to replace radios destroyed or damaged in combat and to supply new units that had discovered they needed the improved communication capabilities. This emergency request, coming so fast after the invasion, showed how badly commanders at all ranks wanted the SCR-300 and how completely they had come to see it not as a luxury addition, but as an absolute necessity for winning battles. When Allied forces burst out from the Normandy beachhead in late July and August 1944 and launched the dash across France toward the German border by September, the SCR-300 continued proving itself constantly in high-speed operations where maintaining radio contact while moving was absolutely critical. Coordinating tanks and infantry, which was essential for successful combined arms tactics, required dependable communication between tank commanders and infantry officers. Armored columns driving deep needed to stay wired to following infantry and to the supply convoys bringing fuel and ammunition. Security forces flanking the advance needed to report enemy movements and emerging threats. Every bit of this rested on radios that functioned while vehicles were rolling, engines roaring, and commanders were making split-second choices in rapidly changing situations. The SCR-300 provided this capability faithfully and consistently. December 1944 brought bitter cold to the Ardennes region of Belgium and Luxembourg. Sub-freezing weather, heavy snowfall, thick fog, and unbroken cloud cover kept Allied aircraft grounded and took away the air dominance the Allies had held since the beaches. Into these conditions, gambling everything on one final throw of the dice, Adolf Hitler unleashed Operation Wacht am Rhein, his last major offensive push in the West. It would become known as the Battle of the Bulge. German tanks and infantry smashed through thin American defensive positions, punching a dangerous salient into the Allied lines that threatened to reach the Meuse River and possibly divide the Allied forces. In the turmoil and disorder of the assault, with American units torn apart and mixed together, with defense lines shattering and reforming, with some American soldiers cut off and trapped behind German lines, communication became absolutely decisive in determining whether American forces would dissolve into isolated groups fighting solo battles, or could hold together enough to mount an organized defense and counterattack. This was the SCR-300's finest hour on the European battlefield. Units that found themselves encircled or separated, units that had lost touch with neighboring positions and with higher command, could maintain radio contact with battalion and regiment leadership through the SCR-300. That radio connection meant surrounded units weren't struggling and fighting in complete isolation. Officers could coordinate their moves, could manage retreats to stronger positions, could construct new defensive lines, and could request reinforcements and supplies because they could speak with higher command, even though German breakthroughs had cut them off physically. Artillery observers, among the most crucial soldiers using the SCR-300 throughout the entire war, could keep calling fire missions even when German advances had partially isolated their observation posts. The ability to rapidly concentrate artillery from multiple gun crews on German armored columns and infantry groups frequently proved to be the crucial factor determining whether a defensive spot would survive or would be smashed by attacking Germans. The SCR 300 allowed commanders to pile artillery fire from several batteries onto priority targets in minutes, creating curtains of detonating shells that could halt or slow German movements. The battles surrounding Bastogne, where the 101st Airborne Division and its attached units were fully surrounded by German troops for over a week, relied entirely on radio communications to organize parachute supply deliveries from Air Force cargo planes, to direct artillery barrages from gun positions both inside and outside the circle, and to coordinate with relief forces battling through German positions to reach the trapped soldiers. Without the dependable communications the SCR 300 provided, protecting Bastogne would have become far harder, perhaps even impossible. When the Battle of the Bulge concluded in late January 1945, with the German assault thoroughly crushed and German formations shoved back to their initial positions with catastrophic losses, American commanders and staff prepared detailed after-action reviews, examining what succeeded and what fell short in the furious fighting. Military officers reviewing the Battle of the Bulge consistently highlighted one piece of equipment as indispensable: the SCR 300 walkie-talkie. When the fighting erupted across frozen European landscapes, American units found themselves scattered beyond their normal formation boundaries. Defensive positions shifted continuously, sometimes hourly. Weather brought literal fog alongside the fog of war. That disorientation that comes when nobody quite knows what's happening around them. In this grinding chaos, the ability to send clear radio signals across several miles became absolutely vital. Without reliable communications, mounting any kind of defense seemed nearly impossible. Launching counterattacks would have been nearly suicidal. The SCR 300 changed everything. American commanders suddenly possessed a communications edge that German forces simply could not match. That advantage in radio capability translated directly into battlefield superiority. Germany's radio systems still depended primarily on AM technology throughout the entire war. While German engineers did develop some FM equipment late in the conflict, it never reached American production volumes. It never achieved comparable reliability in field conditions. It never reached the sophisticated engineering standards that American manufacturers maintained. German backpack radios, like the Verkehrsgerät, resembled the SCR 300 in basic concept, yet they came with serious drawbacks. They weighed significantly more. They failed more frequently under harsh conditions. Some models required external power sources or rechargeable batteries that demanded access to rear area charging equipment, a crippling limitation when combat units got cut off from supply lines for extended periods. Japanese forces in the Pacific Theater operated infantry backpack radios too, but some Japanese designs relied on hand-cranked generators. A soldier would stand there continuously and laboriously cranking a handle, while another soldier operated the radio itself. This arrangement was brutally cumbersome, essentially removing two combat-capable soldiers from action entirely. The cranking soldier exhausted himself. The radio operator's attention stayed fixed on the equipment. The SCR 300 worked completely differently. Self-contained batteries powered it. A single soldier could carry it on his back while keeping both hands free for his weapon. This represented a tactical advantage that multiplied American battlefield effectiveness dramatically. At Galvin Manufacturing Corporation, which officially became Motorola in 1947, production of the SCR 300 remained at maximum capacity throughout the war years. Other licensed manufacturers joined the effort as demand climbed. Eventually, production facilities in liberated France and Italy added to the output. This represented an extraordinary achievement in wartime industrial mobilization. Each SCR 300 contained 18 vacuum tubes of various types, countless resistors, capacitors, transformers, and dozens of other electronic components. Every single component had to meet strict military specifications. Manufacturing required precision assembly work. Every completed radio underwent thorough testing before acceptance and shipment. The company and its licensees produced nearly 50,000 of these intricate machines during the war. Each one had to function reliably because soldiers' lives depended on it working. The engineering team that made this achievement possible deserved recognition extending far beyond headlines about weapons or combat leaders. Daniel Noble received an Army Certificate of Merit for developing the walkie-talkie, a significant honor recognizing civilian wartime contributions. When accepting the award, Noble characteristically praised Henry McNusky, Bill Vogel, Lloyd Morris, and Marion Bond for their crucial roles. He then said something that revealed his character profoundly. He stated that developing the walkie-talkie was merely academic work compared to what soldiers faced on actual battlefields. Those words, expressing genuine humility and recognizing combat soldiers' infinitely greater sacrifice, resonated deeply with the men who carried the SCR 300 into combat. Those soldiers understood completely that no equipment, however innovative or well-designed, could replace courage, sacrifice, and blood. Yet they also knew with equal clarity that reliable equipment made their incredibly difficult jobs somewhat easier. Good equipment increased survival odds. Good equipment made victory more certain and less costly in lives. The SCR 300's influence extended far beyond World War II tactical applications. It represented crucial proof that FM technology worked in military environments, a concept that would shape communications development for decades afterward. Major General Roger B. Colton directed Signal Corps Laboratories in 1938 when the historic and controversial decision came to employ FM in military radios. He clearly grasped the long-term significance of that choice, even while fighting continued. On June 29, 1944, Edwin Howard Armstrong, the brilliant engineer who invented frequency modulation technology, wrote to General Colton acknowledging and praising the importance and courage of his decision. Armstrong called it the most difficult decision of the history of radio that anyone was ever called upon to make. He expressed sincere hope that after the war, what Colton's organization and engineers at companies like Motorola had accomplished in developing and fielding FM military radios could be properly presented to the world and receive deserved recognition. Armstrong had invented frequency modulation technology in 1933 following years of research. He donated free use of all his FM patents to the United States Army during World War II, waiving all royalty payments as his war contribution. He served in advisory capacity to the Signal Corps on FM technical matters. However, Armstrong himself wasn't directly involved in designing the SCR 300. That work fell to Noble's engineering team at Motorola, building upon Armstrong's fundamental invention and applying it to portable military radio challenges. The decision to adopt FM for military radios had been genuinely controversial in both military and civilian radio engineering circles. It demanded the military abandon familiar, proven AM technology that everyone understood and had built radio communications around for decades. It demanded embracing a newer, more complicated system that many respected engineers claimed was too sophisticated and difficult to maintain reliably under field conditions. It required substantial investment in new equipment designs, new manufacturing processes and tooling, new operator training programs, new maintenance personnel preparation, and new logistics systems supporting completely different radio technology. Yet battlefield results proved the decision absolutely correct, despite the controversy and difficulties. The SCR 300 and parallel vehicular FM radios, like the SCR 5008 and SCR 6008, marked the beginning of fundamental military communications transition from AM to FM. That transition would continue through Korea, through Vietnam, into the modern era. Today's military radios, despite incorporating digital signal processing, frequency hopping, encryption, and satellite connectivity, still rely on fundamental FM principles that Daniel Noble and his team successfully implemented in the SCR 300 more than 8 decades ago. The range improvement from the earlier SCR 536 handy talkie represented far more than simple numerical gain. The SCR 536 provided roughly 1 mile of range. The SCR 300 delivered 3 miles in typical operational conditions, sometimes reaching 5 miles in optimal terrain and atmospheric conditions. This represented a fundamental and transformative change in how infantry units and combined arms forces could be commanded and controlled on the battlefield. Before SCR 300 availability, company commanders had to remain relatively close to battalion headquarters to maintain reliable radio contact. This proximity requirement significantly limited tactical flexibility. Commanders often couldn't position themselves where they could best observe enemies, understand tactical situations, and effectively direct their units. The SCR 300's 3-mile range, sometimes more, allowed company commanders to operate several miles from battalion headquarters while maintaining continuous contact. This extended range enabled much more aggressive and flexible tactics. Wider envelopments around enemy flanks became possible. Deeper penetrations into enemy territory could be executed with confidence that reinforcements would arrive if urgently needed, that tactical situations could be addressed with new orders from higher headquarters, that reliable communications would never fail. The psychological impact on soldiers of possessing reliable communications shouldn't be underestimated. Knowing they could call for help if needed, that artillery and air support remained just a radio call away, that higher headquarters tracked their location and understood their situation. All this boosted morale and combat effectiveness in ways difficult to measure but absolutely real. Soldiers feeling isolated, abandoned, and cut off from support fought less effectively and with lower morale than soldiers knowing they remained connected to a larger organization capable of supporting them. The British military, which had pioneered much pre-war military radio technology, recognized the superior capabilities of the American SCR 300. They began developing their own version during the war's latter stages. The wireless set number 31, similar in design and capability to the American BC 1000 component of the SCR 300 system, entered British military service around 1947 to 1948, following testing programs begun in 1947. This represented significant acknowledgement from a nation at radio technology development's forefront that the American FM portable radio design represented the best approach to infantry communications. Adoption of the SCR 300 design concept by the British and subsequently by other Allied nations created important standardization benefits extending well beyond World War II. These benefits became increasingly valuable as the Cold War developed and NATO formation occurred. Allied forces could share maintenance expertise, training programs, and operational procedures. Communications between different nations' forces simplified when using compatible equipment. This interoperability proved valuable in combined operations and collective defense arrangements characterizing NATO. The SCR 300's technical and operational legacy extended far beyond World War II, continuing through Korea and into Vietnam. While the basic vacuum tube design eventually became superseded by lighter, more capable radios using transistor technology, the fundamental concepts and design principles pioneered in the SCR 300 remained standard in military portable radios for many decades. The AN/PRC-10, which replaced the SCR 300 in American service during the Korean War era, weighed approximately half as much while providing similar or slightly better communications performance. The highly successful PRC-25 and PRC-77 radio families that served throughout Vietnam and for decades afterward built directly on the same FM principles the SCR 300 had proven in combat. They incorporated solid-state transistor technology that dramatically reduced size, weight, and power consumption while increasing reliability tremendously. The SCR 300 story ultimately concerns technical courage, innovation against institutional resistance, and willingness to challenge conventional wisdom when you know a better path exists. When Daniel Noble told Major O'Connell in Washington meetings that the Army's AM portable radio plan represented a grave mistake, when he forcefully insisted FM was right for portable military radio, he took very real professional and personal risk. He contradicted established military procurement preferences. He advocated for more complex and potentially more expensive solutions when simpler, cheaper options seemed adequate. He asked busy military officers to trust his technical judgment over their institutional preferences and established practices. Yet Noble understood something others didn't fully grasp. He understood that FM offered genuine fundamental advantages in battlefield communications, justifying additional complexity and cost. He understood that soldiers operating in modern mechanized warfare's electromagnetic hostile environment needed communications working reliably amid massive electrical interference. He understood that clear voice transmission at range limits could mean successful coordination versus catastrophic confusion. He staked his professional reputation on these beliefs. His willingness to fight for what he knew was right paid off in ways that saved countless lives and contributed to winning the war. The engineering team that transformed Noble's vision into working hardware, solving the enormous technical challenges involved in creating battery-powered FM portable radios, meeting all Army demanding specifications, demonstrated focused, urgent, practical innovation, characterizing American engineering and industrial mobilization at its finest during World War II. When Noble presented that specification sheet to Magnuski and told them it was life and death priority for infantry, he wasn't exaggerating dramatically. He stated literal truth. Soldiers' lives would depend on reliable radio performance in combat. The engineering team understood that responsibilities weighed and delivered results exceeding Army specifications and expectations. When Daniel Noble and Henry Magnuski stood 8 miles apart in Kentucky fields during spring 1942, testing their prototype FM radio and achieving crystal-clear communications far beyond the 3-mile requirement, they knew they'd succeeded in creating something technically impressive and important. Neither could have fully understood or predicted the enormous scope and scale of that success, the impact their radio would have on the war and subsequent military communications development. The SCR 300 would serve in every theater where American forces fought. It operated on volcanic Pacific islands, in New Guinea and Philippine jungles, in Italian mountains, in Normandy hedgerows, in Ardennes forests, in Germany's final drives. Infantry privates carried it on their backs through mud and jungle. Artillery forward observers used it calling fire missions from exposed positions under enemy fire. Tank commanders coordinated combined arms operations through it. Airborne troopers jumping into enemy territory used it. Marines hitting hostile beaches relied on it. Special operations forces operating behind enemy lines deployed it. The SCR 300 saved countless lives by enabling timely, accurate artillery fire that broke up enemy attacks before success. It saved lives by allowing isolated units calling for help and receiving reinforcements in time. It saved lives by maintaining command and control that prevented units blundering into ambushes or friendly fire situations. It contributed to victory by giving American and Allied forces decisive battlefield communications advantage and coordination superiority. After war's end, the SCR 300 served as foundation and proof of concept for generations of improved military radios continuing to use and refine FM principles that Noble and his team had proven in combat. Each successive generation of military portable radios built directly on SCR 300 lessons, incorporating new technologies like transistors and integrated circuits while retaining fundamental FM battlefield communications approaches. The battlefield communications capability improvement that the SCR 300 represented was far more than technical achievement worthy of engineering journals and military catalogues. It was war-winning advantage, giving American and Allied forces decisive superiority in commanding, controlling, and coordinating forces on battlefields. That communications superiority translated directly into tactical and operational advantages, helping defeat Axis powers and win the war. That decisive advantage came from one engineer's clear technical vision and courage, advocating for it against institutional resistance. It came from one brilliant engineering team's successful execution of enormously challenging development programs. It came from one company's willingness to embrace innovation and tackle difficult challenges even when outcomes remained uncertain. The SCR 300 stands as enduring testament to what technical insight, engineering excellence, and determined innovation achieve when applied to problems where success literally means the difference between life and death, between victory and defeat. More than 8 decades after those Kentucky Spring prototype tests, we still benefit from Daniel Noble's revolutionary radio legacy and his unwavering determination to give American soldiers the very best communications technology, engineering skill, and manufacturing capability could provide. The SCR 300 story reminds us that technical innovation, courage in challenging conventional wisdom, and excellence in execution can change history's course.